In this video, we're going to explore pH and its relevance to chemistry and, well, to water solutions. So remember that water can be expressed as hydrogen cation combines with the oxygen anion, which is -2. And once we do the crisscross, we get H2O. But we can also express this in terms of H bonding with OH. Water is a very versatile compound, which we can interpret in very different ways and represent it in different ways. So in this case, we're always getting a positive side from water, and we're always getting a negative side, which is the hydroxide ion. And here we're getting a hydrogen ion, which can also be represented as hydronium. So H3O with a plus, and this guy is called hydronium. And pH is basically the measurement of the concentration of hydronium in a water solution. So in this case, if we're a little bit more explicit, the pH scale goes from 0 to 14, which is a value that we obtain from the concentration. And if we're talking about the midpoint, a pH of 7 is said to be neutral. And then once we're higher than 7, all the way up to 14, we're said to be basic or alkaline. And if we're under 7 all the way up to 0, we're acidic. So in this case, as we approach 0, we're very acidic. As we approach 7, we're neutral. And as we approach 14, we're very basic, very alkaline. Okay? So in this case, how does this work out with different things? It's based on concentrations. Solutions are based on concentrations. So if we have pure water with nothing else added to it, and we split it down the middle, we're going to get an equal amount of H's and OH's, because those water molecules are hydrogen and oxygen. And once we split these down the middle, we're going to get hydrogen ions, and we're going to get OH anions right here as well. So equal proportions of both. For every H, there's an OH, right? So if these amounts are equal, what's going to happen? We're going to get a pH that's neutral, that's 7. Once the hydrogen or the hydronium is winning over the amount of hydroxy, or rather of hydroxide, we get that the pH is going to be what? The pH is going to be acidic. So if our hydrogen concentration is high, we're acidic. But on the other hand, if it happens the other way around and we have that the hydrogen concentration is lower than the OH concentration, we have a basic medium or a basic solution. If, once again repeating, H concentration is equal to OH concentration, we have what? A neutral solution, or we have water, basically. That's what we're talking about. So now, when we try to work this out with problems, our main formula is going to be that pH is equal to the negative logarithm of the concentration of hydrogen in the solution, or hydronium. You may find it either way on textbooks, and maybe your teacher is teaching it a different way. But the most simple example is we usually get a scientific notation value, and it's telling us the hydrogen concentration of X substance is 2.36 times 10 to the -3rd. -3 exponent, right? So what we would do is we would just take this directly into the formula, and we would do pH is equal to negative logarithm of this value, because this is very straightforward question. It's just telling us the hydrogen concentration in this water solution is 2.36 times 10 to the -3. So once we punch that into the calculator, and we say negative logarithm of 2.36 times 10 to the -3, we're going to get a pH value of, rounded up to 2 decimals, 2.63. If we remember from this example I gave us in the diagram, if we have a pH between 0 and 7, we're acidic. So this is an acidic solution, okay? So it's quite straightforward. This is a quite straightforward exercise. let's do a reverse exercise, okay? And in this case, if we know that pH is equal to the negative logarithm of the hydronium concentration or hydrogen concentration, what happens when we're given the actual pH and we want to calculate the concentration in reverse? Let's do some algebra with the properties that we have here. So the first thing we would do is we would pass a negative sign to the other side, and we get negative pH equals logarithm of hydrogen concentration. Next step, how do we get rid of the log with a 10 to the, right? 10 to the x is what we're going to do. So once we do 10 to the x, we cancel this out, and we're going to get that hydrogen concentration is going to be equal to 10 to the negative pH. In a sample problem, they might tell you, what is the hydrogen concentration of a solution with a pH of 6.7? So if our pH is 6.7, we plug it into the formula right here, and we're going to use our calculator, 10 to the negative 6.7, and this is going to give us the concentration of hydronium, and this gives us a 1.995 times 10 to the negative 7, which is equal to the concentration of hydrogen in this specific solution. So once again, let's do a little recap of this. pH equals the negative logarithm of the concentration of hydrogen or hydronium. And if we reverse this formula, we know that the concentration of hydronium is going to be equal to 10 to the negative pH. Remember when I said that the basic scale of pH goes from 0 to 14? Well, it's complementary because remember, H and OH go together. So there's another aspect which we have to consider. If I take the pH value and I add it to the pOH value, this is going to give me 14. So these three formulas are really what's going to help you answer most of the exercises, okay? Now, there are other little tricks that we need to find out and solve, because just as pOH is how acidic or basic a water solution is, the pOH is going to be how acidic or basic the water is, but in reverse. What do I mean in reverse? If I get a value that's between 0 and 7 of pH, it's acidic. But if I get a value of pOH between 0 and 7, it's basic. But how do we usually learn it when we're being taught? Again, pH less than 7, acid. pH equals to 7, neutral. pH greater than 7, basic. But the opposite is true for pOH. If we get a value of pOH that's less than 7, what do we get? Basic. If we get a pOH value that's equal to 7, neutral. And if we get a pOH value that's greater than 7, we are what? Acidic. In pOH, which is the opposite. pOH, just like pH, is equal to negative logarithm of hydrogen concentration. pOH is equal to negative logarithm of OH concentration. And concentration of OH is equal to 10 to the negative pOH. And then pH plus pOH equals 14. So if we keep this in mind, we can really answer any type of exercise. Let's talk about a specific example with an acid. So let's say a solution of hydrochloric acid has a hydrogen concentration of 4.77 times 10 to the negative 4 power. And it tells you calculate pH, calculate pOH, and calculate the concentration of OH. Let's take this step by step. First of all, we know that our formula is pH is equal to the negative logarithm of hydrogen concentration, which we were already given. So in order to calculate the pH, I just go pH is equal to negative log of 4.77 times 10 to the negative 4. And if we punch this into the calculator with a lot of care and making sure that we're not making any mistakes, we're going to get a pretty straightforward answer. Let's see. Negative logarithm of 4.77 times 10 to the negative 4. We get a rounded up value of the pH is 3.32. Now remember, from the other formula, pH plus pOH equals 14. So in this case, when we want to calculate pOH, it's pH plus pOH equals 14. The only thing we're going to do is we're just going to plug this value here. And once we do that, we have 3.32 plus pOH equals 14, meaning that pOH is equal to 14 minus 3.32, which is very simple. 3.32, it's 10.68, okay, is the pH, pOH. We box it, we box this one, and what happens? Now we want to see that the solution is what? Since the pH is lower than 7, it's acidic. It's an acidic solution. And that makes sense because if my pH is greater than 7, pOH is greater than 7, it's acidic. So that makes sense. pH less than 7, acid. pOH greater than 7, acid. Why? Because we're talking about the same acidic solution, okay? Now, in this case, we're using H because it's giving us the H right off the bat. Now, how do we calculate the OH concentration? Remember, if pOH is equal to the negative logarithm of the OH concentration, then the OH concentration is going to be equal to 10 to the negative pOH. And what we do is we punch this number that we calculated from our subtraction right into that number, 10 to the negative 10.68. And that's going to give us a concentration of OH of, and then we just make sure that we're copying out down these numbers properly, 10 to the negative 11th, and this is our answer for that. So one thing leads to another. Now, what we really need to consider here is always read the problem and see what it's asking you about. If it's giving you a concentration of acids, hydrochloric acid, sulfuric acid, phosphoric acid, yeah, basically these three are the ones that most frequently show up. Or if it's giving you a base, NaOH, which is sodium hydroxide, magnesium hydroxide, aluminum hydroxide. So remember, HOH, pH, pOH, bases, acids. This depends if you're going to calculate pH or pOH, and then from the subtraction, you're going to do the rest, okay? Let's think about another final type of problem. Not a type, but it's just a different kind of problem. Let's say the pH, this one's going to be a little bit tricky, of a sodium hydroxide solution is 12.11. So that's consistent because remember, if the pH is greater than 7, it's basic. Sodium hydroxide is a base. And then it's asking us to calculate hydrogen concentration. It's asking us to calculate OH concentration, and it's asking us to calculate pOH. Okay? So this is going to be quite simple. Let's remember our formulas. First of all, if we want to calculate the pH, it's already calculated, it's given. So we can easily calculate the pOH because pH equal plus pOH equals 14. meaning that if we subtract the pH from the 14, the pOH is going to be equal to 14 minus pH, which is pOH is equal to 14 minus 12.11. And then we already have this right off the bat. So 14 minus 12.11 is going to give us 1.89. Okay? Now, this is consistent because if the pH is less than 7, pOH is less than 7, it's basic, which is the same as having a pH greater than 7, it's basic, okay? Remember, these are opposite and complementary. Now, this is our pOH, done. Now, remember the formula. The formula says that H, concentration, is equal to 10 to the negative pH, and OH concentration is equal to 10 to the negative pOH. We already have these values, so we just need to plug them in. And this pH is 12.1, of course, with its negative number. And the pOH, which we subtracted, is 1.89. So we just plug that into the calculator, and we say 10 to the negative 12.11. And that gives us an answer rounded up of 7.76 times 10 to the negative 13. And this one gives us 10 to the negative 1.89. And this gives us a concentration of 0.013. Okay? And these are our concentrations. So that's a basic, simple tutorial on very basic, very simple pH problems.